Welcome everyone! Today we'll learn how to use generics in .NET. So go to Visual Studio and create a new .NET Core empty application. Define the name, select the .NET version and create a project. To understand the relevance of generics in .NET, consider a shopping API that finds a product based on an input name. To do this, we can use the object type to check whether the two values match. This is possible because all .NET data types are inherited from system.object. So let's create a helper static class to create a method to compare the values. So create a new class called helper, declare this class as static, and create a new method that will be static called matches. And this method will return a Boolean value. We'll pass two parameters, the two values to compare. So both values will be objects, and we'll compare the equality by using the equals method provided by system.object. Now create a new class called product and define two properties. The first one will be the name, and a second property that will be the price. We'll compare the name of the products to find a product in the API. So go to the program.cs file and create a new endpoint. This will be a post endpoint to get the products. So define a root, and from body we'll pass a simple DTO with a single property, which will be the name. So let's declare this class in the product class called body, and we'll pass the input name provided by the user. Go back and add the reference to this body class. So let's create an array of products. So reference the product class, and let's add 3 hard-coded products. The products are added. Now declare a for each statement to iterate over the products, and we'll create a Boolean variable to verify if the product is found by using the matches method from the helper class. So reference the helper static class and invoke the matches function. We'll pass the name of the product and we'll compare against the input name, which comes from the body. So we'll check if the product is found. We return an OK status code with the product. If the product is not found, we'll return a not found status code. Let's run the API. Let's copy the API URL and open Postman to test the API endpoint. Copy the URL and add the product's root. And from body, we'll pass a name. Let's copy any product name and send request. So we're getting the product properties, the name and the price, using the matches method from the helper class. This approach looks good, but has two problems. The method is not type safe. The parameters can have different types, and performance is affected by boxing the data type into an object type. To solve these issues, we can create 2 overloading methods for each data type in order to compare the product properties, which is based on the name or can be the price property. So let's stop the application and create 2 overloading methods. Let's comment that the first one. So we'll replace the object data type by a string when we want to compare the name property from a product, and add a second method to compare decimal values. Now go back to the program.cs file. We'll find a product based on the price. Go back and we'll call the second overloading method based on the price. Run the API. Go to Postman, and instead of passing the name, we'll pass the price. Let's copy any price from the third product. Let's send request, and we have the product. Go back and stop the application. we solve the first two issues from the matches helper method. This approach looks good, but a new issue arises. For each new data type we want to add to the product entity, for instance, create a date, which is a date time data type, and an ID, which can be a quit, a new integer property. For each new data type, we need to create a new overloading method. And here comes generics in .NET to solve these issues. Generics are classes, methods, or other structures that have type parameters or placeholders. Use them when you need a .NET supported generic data type that automatically works with different data types. We can transform this static class as a generic one. So let's add a new type parameter in this helper static class of type T, and we can use this parameter type. Let's comment out these methods. For the first method, let's uncomment it out. For the two data types, we'll place as the placeholder or type parameter that we define in this generic static class. And now we can compare the equality of the two values. So go back to the API. In this API option, we need to specify the actual type to substitute the type parameter from the static generic class. So in the helper static class, let's specify this type as decimal and test the API. Go to Postman and send request. It's working fine. Now go back and replace this parameter type as a string, and we'll compare, or we'll find a product based on the name. So go to the body class and pass an input name. Go back and compare the names, save it, and run the API again. Let's copy the name of this second product, go to Postman and add the input name, send request, and we have the information about the product with name jacket. Stop the application. Generics provides three main benefits. Type safety. Data type validation is enforced at compile time. Code reusability. Type parameters can be reused for different instances of the generic type. Better performance. Generic collection types generally performs better because there's no need to box the value types. It is possible to define a generic method. So go to the helper class, and instead of creating a generic static class, we'll add a new type parameter for this generic method of type T. And the parameters can use this parameter type, or we can use this parameter type as a return value. So go back, and instead of defining the parameter type in the helper static class, we'll define it in the generic method. Yeah, there's no need to define the generic parameter because we implicitly specified this generic type based on the name type. So run the API and test again the product's endpoint. We have the same result. So go back, stop the application. We can use constraints to limit the type parameters from a generic type. So go to the product entity and create a second entity called order. Let's define a name property and a second property called created date. And the product and the order entities had the name property in common. So we'll create an interface called iCommonEntity to define this common property, and each class, product, and order will implement this iCommonEntity. Do the same for the order entity, and go back to the helper class. We'll replace this matches method. So we'll add a new generic type parameter in the helper static class. So let's define it as T, and we'll use the where keyword to define a constraint for this type parameter. We'll specify this constraint that the T parameter type is a class, and also that this class will implement the ICommonEntity interface. And in the matches method, we'll add a new parameter type called p, and for the type parameter defined in the help static class, this will be the item itself, and the p parameter type from the generic method will be the value to compare. So look that we can access the name property from this item because we add the constraint that this class should implement the ICommonEntity. So we access the name property and we'll validate the equality based on the value passed by a parameter. So go to the program.cs file and define the type parameter from this help static class. In this case will be the product class. So pass the item and the name of the input body and run the API. Go to Postman and test again. It returns the same result. Go back to the API, stop the application. Let's create a second API action to find an order. So define the root. We'll pass the name of the order. Let's define an order array called order. Define the name and the created date. Let's create 3 orders. We'll iterate over the orders. Let's rename this array as orders and this Boolean property as order found. So the generic type parameter for this help static class will be the order class, and we'll verify the matching between the name of the order and the name provided from body. If order is found, we'll return the item. If not, we'll return a not found status code. So test the API. Go to Postman and define the order root from this request. Let's copy any name of the order, in this case order 2, and send request. We have the information about this order. Go back to the API, stop the application. The generic type cannot substitute type arguments that don't satisfy the constraint. For example, if we pass the body class, it will throw an error because this class doesn't satisfy the constraints defined in the generic static class. So let's keep it as order class. And look at that, we're reusing the same generic method in both API actions. Finally, we can use generic collection classes and other generic types in .NET, such as list and dictionary. So we can define this product array as a list. So this is a generic collection and we define the type parameter as product. And let's comment it out in this for each statement. We can use a generic method to find the product. So create a new variable called product and use the find generic method to find a product based on the predicate. So this is a generic method. So in the predicate, we'll add a lambda function and we'll access the name property and we'll check a product when the name is equal to the input body. So if the product is null, the product is not found, so we'll return a not found status code. Otherwise, we'll return an OK status code with the product. Let's use the same approach to find an order. So let's replace this array of orders by a generic list and copy these 2 lines, comment the for each statement and the last line from this API action. So we'll find an order based on the orders. We'll find an order based on the name. So if the order is null, we'll return a not found, otherwise we'll return the order. So let's run the API, open Postman and search for an order with this name. So far so good. Let's test the product endpoint, send request, and we have the information about the product with name shoe. So in this demo, we learned how to use generics in .NET.